So you can see where I need to use BGP. So IGP protocols like REAP, EAGRP and OSPF can handle up to 1000 prefixes in their routing table, but BGP can maintain lakhs of prefixes. Okay. BGP can handle lakhs of prefixes in their routing table. BGP stands for Border Gateway Routing Protocol. IGP can configure within AS, but BGP can be configured within AS as well and between AS as well. Okay, like this is a scenario. In this scenario, we'll configure eBGP because on router number 1 I am running AS number 100, on router number 2 I am running AS 200. After that, IGP protocol can be configured with a directly connected router, but BGP can be configured with directly connected router as well and indirectly connected router as well. Let's say in this topology R1, R2, R3, between router 1 and router 2 you can run IGP protocol, between router 2 and router 3 you can run IGP protocol, but you cannot run IGP protocol to form neighborship between router 1 and router 3. But with the help of BGP you can form neighborship between router 1 and router 3 directly. Okay, then we have two types of neighborship in BGP. One is IBGP, another one is eBGP. So when we are configuring BGP between two routers on same autonomous system number, that type of BGP neighborship is IBGP. Whenever we are configuring BGP on two router and both router are using different AS number, that type of BGP is eBGP, and this is the configuration. Okay, I have captured all the things in recording again. Yes or no?
Thank you.
Yes, yes.
Okay, so this is the command. After that, on neighborship will come up, then we can advertise network. Let's say router 1 have one network, that is 10.1.1.0/24. So on router number 1 I can run network command, network 10.1.1.0, and in BGP you have to define subnet mask, mask 255.255.255.0. Guys, whatever prefixes you are advertising in BGP, same prefix should be in the routing table with same prefix length, with same subnet mask, then only prefix will come in BGP. Okay, now I am going to show you practically. This is the concept, only basic concept of BGP. In BGP, interviewer will also ask you question from neighborship only. They are not going to ask you advanced question. Okay, so let me open my GNS3, and here I am going to design one topology. R1, R2. First of all, I will configure IBGP neighborship between router 1 and router 2. Okay. Let me turn on the device, and let's say on router number 1 I will create one loopback. On that loopback I will run IP 10.1.1.0/24. This loopback is like your LAN network, as you already know. On router number 2 also, let's say I am running one loopback 20.1.1.0/24. Through BGP I want to exchange these two prefixes with each other. Okay, so on router number 1, first of all I need to configure IP. Between router 1 and router 2 I will use 12 network, 12.1.1.0/24 network. As you already know, I always use this network between router 1 and router 2. Okay, so let me take you to R1. On R1 I am going to configure IP first, interface F0/0, no set, and IP address 12.1.1.1, 255.255.255.0, exit interface loopback 1, and IP address is 10.1.1.1, 255.255.255.0. Should I improve the configuration speed, guys? Typing speed, or it's fine?
I think it's fine.
It's fine. You are not getting bored now while configuring IP address. When I am configuring something on router, if anyone is getting bored, then please let me know. I will increase the speed.
Okay.
No, do not increase. That's okay.
That's okay. Okay. So I have configured the IP address on both router. Do so IP interface brief as screwed and assigned. We can check. Okay, and if you want to ping 12.1.1.1, you can see ping will also work. 12.1.1.1 ping is working. Now I need to configure BGP, because you can see if you will check routing table, so IP route, router 2 don't have 10 network 10.1.1.0. in the same way router 1 don't have 20.1.1.0 network. Yes or no? Yes or no?
Yes.
So till now we had understand IGP configuration, and today I am going to configure BGP. So first of all, on router number 2, router number 1, router BGP 100. I am running same AS number on both router, BGP AS 100 here and BGP AS 100 on router number 2 also. Same autonomous system number. So which type of neighborship will come up? IBGP.
IGP.
IBGP.
IBGP, yeah.
So here I am going to say neighbor. Who is your neighbor? 12.1.1.2, and neighbor remote AS is 100. That's it. On router number 2, config T, router BGP 100 and neighbor 12.1.1.1, and remote AS is 100. Soon BGP neighborship will come up. BGP is an application layer protocol, guys. Okay, see here. BGP neighborship is up. How I will verify? By running command show IP BGP summary. This is command to check neighbor table. So there is one neighbor 12.1.1.2, 12.1.1.2. You can see the AS number of neighbor. You can see the version of BGP. So we are using BGP version 4, and this is how many messages it have received from their neighbor is 4, and how many messages it have sent to their neighbor is also 4. Okay, uptime is till when this neighbor is up, 24 seconds. That's it. Okay, now I am going to advertise network in BGP. So go to router 1, router BGP 100, and again I am going to say network 10.1.1.0 mask 255.255.255.0. That's it. After advertising this network on router number 1, you can check on router 2. So IP BGP, so IP route BGP, so IP route BGP. So you can see router 2 have received this network. Yes or no?
Yes.
And BGP table, so IP BGP. This is command to check BGP table. In BGP table also you can see, like database in BGP, routers maintain BGP table. 3 table maintained by BGP. One is neighbor table, second one is BGP table. So IP BGP summary, this is neighbor table. Then so IP BGP, this is BGP table, and then so IP route BGP, this is routing table. Okay, now on router number 2 also I am going to advertise 20 network. So router BGP 100 and network 20.1.1.0, mask is 255.255.255.0. So router 1 will also receive this network, you can see, and now ping
So,
will also work. Yes.
like we already configure BGP on interfaces, right? Why we also
No, we cannot
advertise network?
configure BGP on interfaces.
Oh, we cannot. We just advertise on network, right?
Only OSPF routing protocol can be configured on interface.
Oh, okay.
Okay, and see ping is also working. Okay, Now here I am going to change the AS number to 200. Then which type of neighborship will form? See, now if I am running show IP BGP summary. I am not able to see anywhere that which type of neighbor it is, iBGP or eBGP. Yes or no? So you have to run command show IP BGP neighbor to check the detailed information of neighbor. You will run this command. So when I am running show IP BGP neighbor, see the information, internal link. That means 12.1.1.1 is my iBGP neighbor, internal BGP neighbor. Okay. Now I am going to remove BGP configuration from both router. I will configure eBGP. No router BGP 100. On router number 2 also I am going to say no router BGP 100. No router BGP 100. Done. I have removed the BGP configuration from both router. I'm going to configure BGP 100 on router number 1 and BGP 200 on router number 2. So router BGP 100 and neighbor 12.1.1.2 whose remote AS is this time not 100, 200, and network 10.1.1.0 mask 255.255.255.0. That's it. On router number 2 also I will say router BGP 200 and neighbor 12.1.1.1 and remote AS is 100. Getting my point? See, on router number 2 I am saying router BGP 200 and neighbor AS number is 100. Again you can see BGP neighborship is up. I am going to now advertise network 20.1.1.0 mask is 255.255.255.0, and this time again on router number 1 if you will check so IP BGP summary BGP neighbor table, so you can see 12.1.1.2 is neighbor, and this time again here I am not able to see which type of neighbor it is, so I will run command what, so IP BGP neighbor to check detailed information, and when I am checking the detailed information here we are able to see external link. Yes or no?
Yes, question here.
Yes.
Yeah, so if we advertise network ID, right?
Okay.
So it's the routers have to pick up the neighbor, right? If we, for example, if we advertise and router one, router two network, right?
Okay.
So it will pick up the neighbor. So why we configure neighbor ID as well?
No, I have not advertised this 2L network, na. I have advertised only this network.
Oh, okay, I mean LAN network. Okay, got it.
Yes, LAN network. Dynamic neighborship is not supported by BGP. In BGP, we cannot configure dynamic neighborship. Okay. And so IP route BGP, you can see this router have received 20 network, and so IP BGP, this is BGP table. In BGP table, you can see 10 and 20 both network are there. Is it clear? From
Yeah.
here I can again ping to 20.1.1.1 if source is 10.1.1.1. See, ping is working. So this is eBGP configuration. Okay, again I am going to remove BGP configuration. Say no router BGP 100 here, and on router number 2 I am going to say no router BGP 200. No router BGP 200. Okay, and I am going to connect one more router here, R3. I am going to remove this loopback also from here, and I am going to create one loopback on router number 3. In real time, this is how we are using BGP. We will form BGP neighborship between router 1 and router 3. On both router, I will create one loopback, let's say. On router number 1, I have one loopback that is 1.1.1.1. This is LAN network. and 1.1.1, and router number 3, this is LAN network, and there is one loopback 3.3.3. Through loopback interface I will form BGP neighborship. I will not configure BGP on router number 2. I will configure BGP only on router number 1 and on router number 3. Let's say BGP 100. So that is also fine. That is also fine. I can configure BGP neighborship between router 1 and router 3 directly. I don't need to configure BGP on router. Let's say router 2 hardware is not good. Router 2 cannot handle lakhs of prefixes, but router 1 have lakhs of prefixes which router 1 need to share with router 3. So only router 1 and router 3 can handle lakhs of prefixes, so I cannot configure BGP on router number 2. Directly I can form BGP neighborship between router 1 and router 3 through loopback interface as well. See, on router number 1 what I am going to say, first of all let me configure the IP on router 2. One extra interface I have added there. Interface loopback 1, first of all I am going to say no IP address on loopback interface, and directly I can say no loopback, no interface loopback 1. Done. And interface f1/0 no set IP address 23.1.1.2 255.255.255.0. I have configured the IP address on both physical interface of router 2. So IP interface brief exclude unassign. You can see. Now I don't need to configure anything on router number 2. Directly I am going to configure IP address on R3. So let me access router 3 also, and config T interface f0/0 no set, and IP address is 23.1.1.3 255.255.255.0. Exit interface loopback, let's say 10, and IP address 30.1.1.1 255.255.255.0, and interface loopback 1, IP address is 3.3.3. I have created two loopback on router number 3. One is 3.3.3 and one is 30.1.1.1. If you want to check, so IP interface brief exclude unassign. You can see. In the same way on router number 1 also I am going to create one loopback 1.1.1. 1 second guys. Okay, so on router number 1 I am going to say interface loopback 1, IP address is 1.1.1.1 255.255.255.0. Exit interface loopback 10, and IP address is 10.1.1.1 255.255.255.0. See, now you want to form BGP neighborship between 1.1.1 and 3.3.3. This is how in real time also we are using BGP. Now here one requirement is there. What is the requirement? Requirement is 1.1.1 and 3.3.3 should be reachable with each other. Then only we can form BGP neighborship. Because now if I will tell to router 1 that your neighbor is 3.3.3, so how it can forward any message of BGP to 3.3.3, because 3.3.3 is not available in routing table. So for reachability between 1.1.1 and 3.3.3, I will use any IGP protocol. So you can use any IGP protocol. I am going to use, let's say, OSPF. I'm going to use OSPF. In OSPF, I'm using OSPF, let's say 1 and area 0, just to make reachability between router 1 and router 2. I will not share this prefix in OSPF. This prefix will be exchanged by BGP, because you consider that this is not a single prefix, this is lakhs of prefix. Like this, there are lakhs of prefixes which I want to share through BGP, but I want to make reachability between router 1 and router 3 through OSPF. So on all router, first of all I will configure OSPF routing protocol. You can configure any routing protocol. You can configure a static routing as well. Okay guys. So router OSPF 1, router ID 1.1.1.1, and exit interface loopback 1, IP OSPF1 area 0, exit interface F0/0, IP OSPF1 area 0. This is OSPF configuration on router number 1. Let me configure OSPF on R2. Config T, router OSPF1, and router ID is, let's say, 2.2.2, exit interface F0/0, IP OSPF1 area 0, exit interface F1/0, IP OSPF1 area 0. Now, soon OSPF neighborship will come. So IP OSPF neighborship is in two-way state. Soon it will come in full state. Wait till then. Let me configure OSPF on R3 also. Router OSPF1, router ID 3.3.3.3, exit interface F0/0, IP OSPF1 area 0, interface loopback 1, IP OSPF1 area 0. So IP OSPF neighbor. Wait for some time. OSPF neighborship will come up. It will take some time. Two-way on router number 2. Okay, there is OSPF neighborship between router 1 and router 2 full, and here this is in access start state. Wait for some time. It will also come in full state. Now you can see neighborship is fine. Now on router number 1 or on any router, you can verify the routing table. So IP route OSPF. Router 1 have 23 network. Soon it will receive 3.3.3 also. You can see it have received 3.3.3 network, but it have not received 30 network because I have not advertised 30 network in OSPF. On router number 3, so IP route OSPF, it have received 1.1.1, but it have not received 10.1.1.0 because I have not advertised 10.1.1 in OSPF. I want to share this prefix, these two prefix through BGP routing protocol between router 1 and router 2. Means router 2 should not receive these two prefix. Okay, so on router number 1, I am going to say router BGP 100 and neighbor 3.3.3.3 and remote AS of neighbor is 100. On router number 3 also I will say router BGP 100 and neighbor 1.1.1.1 whose remote AS is 100. Still neighborship will not come up because see guys, when I have tell to router 1 your neighbor is 3.3.3, right? And to router number 3 I have tell your neighbor is 1.1.1. But when router 1 will send any message of BGP, in the message source will be what? Source will be the 12.1.1.1 exit interface IP address. So actually I need to tell to router 1 that whenever you will send any message to your neighbor 3.3.3, always attach loopback IP address as a source IP address. So I am going to say neighbor 3.3.3.3 and update source loopback 1. And on router number 3 also I will say neighbor 1.1.1 and update source loopback 1. Now BGP neighborship will come up. See here. Okay, so IP BGP summary 3.3.3 is neighbor and 3.3 is neighbor. Which type of neighbor it is? So IP BGP neighbor. I can check the detailed information and here we are able to see internal link. Means 3.3.3 is internal router. Now I can exchange the prefixes between router 1 and router 3 directly. See, router BGP 100 and network 10.1.1.0 mask 255.255.255.0. Go to R3, say network 30.1.1.0 and mask is 255.255.255.0. If you will check BGP table, so IP BGP, you can see 10 network is also there and 30 network is also there, and so IP route BGP, you can see the routing table of router 3, it have learned 10 network. But on router number 2, if you will check routing table, so IP route, you can see these two network is not there. Yes or no? Getting my point, guys?
Yes.
So in real time also we are exchanging lakhs of prefixes through BGP, with indirectly connected neighbor. Like between router 1 and router 3, there are lots of router, there are lots of path available. Okay, so I don't want to inject this prefix inside the router which between router 1 and router 3, but I want to share directly between router 1 and router 3 to these prefixes, so I can achieve that through BGP, and that's why we are using BGP. And this is how in real time also I am using BGP. Do you want to see how I am using BGP in real time? Then I can make one topology of real time, and some days I will show you that also. For now, is it clear? So there are two
Yes.
types of neighborship in BGP, IBGP, eBGP. We can form BGP neighborship with a directly connected router also and with indirectly connected router also. Whenever we will configure indirectly connected neighborship, the requirement is very simple that IP address should be reachable with each other. Okay? Otherwise, we don't have any problem. Because let's say between router 1 and router 3, I have one more router. Let me configure this router also and let me enable OSPF. So on router number 1, IP OSPF1 area 0. I have enabled OSPF on this router also. Now if R3 will goes, R2 will goes down, then also I don't have problem. BGP neighborship will be up. Why? Because still 1.1.1 and 3.3.3 is reachable via router number 4. Getting my point? See on router number 1. So IP, BGP, summary. Neighborship is fine, and I am going to down F0/0. Config T, interface F0/0 says shutdown. I have done the interface. OSPF neighborship has goes down between router 1 and router 2, but you can see BGP neighborship is still up. Yes or no? So this is the benefit of configuring BGP with the help of loopback interface, because until and unless 1.1.1 and 3.3.3 is reachable, your BGP neighborship will be up, because you have configured BGP neighborship with loopback interface IP address. And now 1.1.1 and 3.3.3 is reachable via router number 4. So I don't have any problem. If any link will goes down, no problem. Interface F0/0, no sir. So that's why I'm saying, see, OSPF neighborship is going down between router 1 and router 2. Then also BGP neighborship is not impacting, right? BGP neighborship is still fine. Is it clear?
Yes.
So that's all about BGP.
So BGP is